There's a couple of the most common questions from the very first section here. If you're getting stuck, hopefully this will kind of get you moving along. So the first part here, 29, asked to describe any changes to the parabola from the parent graph and what's the vertex. So I'm going to do this by completing the square, and I'm going to change h of x to y. I think it's just easier to work with. You can certainly leave it that way. It's just more stuff to write. The very first step that I like to do is always to subtract the constant on both sides. So I'm going to rewrite that as a y, and then I'll put minus 21. Now over here, if this is now subtracted away, this is all that's left, and you always take out the leading coefficient. No matter what, you divide that out, whatever's in front of x squared. Now when I take that out, in this case, it was kind of nice that they both had a 4 in common, so x squared minus 1 is what's left in the parentheses. Now I'm going to kind of leave some space there because I do want to complete the square. Should have been 1x right there. I do want to complete the square, so I'm going to go ahead and set everything up to make that happen. In the process, we take half of the number in front of x, which is 1, so 1/2, and we square it, so plus 1/4 over here. Now I completely made that up. That wasn't there. I introduced it. I thought it was a good thing to do. That means I got to do it over here. Now, inside the parentheses, I introduced a 1/4. As far as the right side of the equation goes, I introduced a 1, because if I distribute this 4 all the way out, 4 times 1/4 is 1. So really, in a weird way of writing it, I introduced a 1 over there. So that means I need to add 1 on this side as well to balance it out. So y minus 20 now on the left side. And we'll leave that 4 out front, and now we can condense this back down. It's a perfect square binomial. It's going to be x minus half of this term. That's just sort of the pattern, but you could certainly factor if you wanted to and see how it would play out. But that's the pattern, x minus that middle term divided by 2. That's the term that will be squared. And now to wrap it up, of course you could substitute h of x back into here if you wanted to. I think to answer the question, that's kind of pointless, but you could make it proper. Add 20 to both sides. So to get all this stuff, and the book's probably going to differ a little bit from what I say, because I'm going to probably add some more stuff here, and that's fine. It just says describe, so it wasn't very specific. The vertex was something I definitely wanted. That's 1/2 20. Anything in parentheses with x is always the opposite. It's a positive 1/2, and then the 20 up to at the end is the y coordinate for your vertex. So I think the book stops at this opens up, which is definitely true. But I think it's important to think about this 4 being here. So this thing is vertically stretched 4 times more than you would normally have it. So usually if you go over 1, up 1, this went up 4. Usually next time you go over 1 more, you go up 3. This one went up 12. So I'm going to say a vertical stretch 4 times. 4 times what it originally was. All right, these last 3 are pretty similar. I chose 37 just to pick one to get started. Really, honestly, I think they're kind of interchangeable. 37 had a graph. I just picked a couple points off of it. Now, there were 3 points. You're definitely going to want the vertex, I guarantee it, but the other 2 points, you can just pick one. I chose that one, 1, 0, no particular reason. It looked a little easier to deal with, but it really doesn't matter. So where I would begin with this type, you're supposed to come up with the equation. So I would start with a general equation for a parabola. Y equals a x minus h squared plus k. That's your standard form. Let's put in what we do know, because pretty quickly you're going to see you know almost everything here. So for a y coordinate, well, I've got a point with a y coordinate. I don't know a, but I've got a point with an x coordinate. H is the x coordinate for the vertex. And k is 4. Let's see what we got. 0 is a times, now that's going to be 1 plus 1 really, so 2. 2 squared is going to be 4. All right, so make it look a little cleaner. 4a plus 4, so I would try to solve this for a. I'm going to subtract 4. It's pretty much basic algebra at this point. 5 by 4. A is going to be negative 1. All right, probably shouldn't circle it because I'm not quite done, but we've got to put this back into our standard form. Now in standard form, you have y and x left as variables, everything else is filled in. So we know it's going to be a -1 for a, x minus -1 for h. So I'm going to say x plus 1. And plus k, which is 4. So this will be the equation for my parabola in standard form. These two problems will probably give you a pretty good idea of the rest of the section. So if you're having some trouble, hopefully it's enough to kind of push you over the edge, get you going. Some of the other problems are in the website posted already if you want to see them written out. But I'll do a couple of these live here or in video here so you can see how it works. So 61, these are kind of tricky, but the sum of the first and twice the second is 24. So it's telling you there's two numbers. So I'm just going to call them A and B. So the sum of the first and twice the second is 24. Now in the directions it said that you're trying to maximize the product of these two numbers. And it may have not been super clear that's what they were asking for, but that's what it was saying. So I'm going to say product A comma B is A times B. So that's its own little formula. These are two separate formulas. I've got two variables, so I need two equations to solve for these together, or to find each one. That's what we're saying, the product of A and B. And this is saying I can plug in A and B, and it's A times B. That's the product. All right, so I'd really like to be able to graph this with only getting one of these plugged in. To make this easier, let's see if I can do the product just given one of these variables. And I kind of want to maybe say product given B, because A is really easy to solve for, and I could substitute it back in. It really doesn't matter which way you go, but you might want to do that. You might want to look here first, see which one's easiest to solve for, and then think about what that would look like if you substitute it in. So let me kind of do it backwards that way. And subtract 2b, so 24 minus 2b is A. So that means that A could be substituted in over here. So I'm going to say product given B, because I just want to be able to take one variable, plug it in, and get the product out. That's what I'm really hoping for here. So if A is that stuff, 24 minus 2b, and I multiply it by the b that's already there, let's just see what that looks like. So product given B is 24b minus 2b squared. Okay, so we're supposed to find or at least we're supposed to find the two numbers A and B that maximize this. So if we kind of think ahead, if we graph this, and it'd be good to do it without a calculator, because ultimately on this quiz you can't use a calculator. I don't think I've decided quite yet, but it's probably all going to be non-calculator, so I'm going to go ahead and prepare you that way. So in this case, this would be the B axis, because I'm given B, just because that's the variable I made up. And the Y axis would actually tell you the product. So I'd set it up that way. All right, I'm going to try to do this without a calculator. I am going to do this without a calculator because I want to see what's going to happen. Now, these points won't be precise, but wherever the maximum happens, that's the input for B that'll give me the maximum, and the Y value there, the P value, that's the product, the maximum product I could have. So that's what I want to do. I want to find the vertex, and we can find the vertex by completing the square. So I'm going to, I guess we can, well, I feel better calling that Y, just to make this easier to deal with. And hopefully it's not too crazy. I'm going to go ahead and think about how this would be maybe written with negative 2b squared first, plus 24b. I'm going to factor that negative 2 out from the b squared. So if I factored out negative 2 from positive 24, it would be negative 12b. And just redistribute to see if it checks out, and it seems like it will. So now we'll start completing the square. Well, I would take half of 12 to get 6, and then square it, and that'd be 36. But technically there was a negative 2 out front, so technically I introduced a negative 72 to this side. So to balance it out, I'll do the same thing over here. So now we have y minus 72 is negative 2, and then I'm going to condense this back down. And the way it works is it's this variable minus half of that variable squared. And then we could kick the 72 back over, just add it to both sides. And there we go. That's going to be our vertex right there. Our vertex is going to happen at 672. So 6 is actually the value for B that's going to maximize the product. It's going to be one of the two numbers I'm looking for. So what I was really trying to do in the beginning is find A and find B. And I just figured out that B is 6. Because again, that's the B value that's going to maximize my product here. And once I know that B is 6, I can basically go back and plug it in anywhere that makes sense. I think this is the place where it makes the most sense, where I can solve for A. So A would equal 24 minus 2 times 6, because that's what B would equal. We're maximizing this thing. So 24 minus 12, it's going to be 12. So that's your A value. So those are your two numbers that they would fit the description when you take the first one, 12, and add twice the second. So 6 times 2 is 12. You get 24. That works. And if you try multiplying two numbers that fit this description together, those are the two that would give you the biggest product possible. All right, 64, we're making a kid cage here. We got a daycare here, trying to cage in a play area. So it tells us there's a rectangle, and this is what they're giving us, but I'm going to add some more here. Because if it's a rectangle, then this is also X, and so is this. And then this one's Y, and this one's Y. So those are things we can kind of fill in right away. Now, they tell me that the perimeter, the amount of fence I have to work with, is 200 feet. So 200 would equal 4 X sections plus 3 Y sections. So that's one thing I know to be true. And I'm trying to maximize the area of this thing. Well, the area, and I'll say it this way, area given X, because I'd really like to work it out where I'm given one variable in and I find the area out. So the area given X would be 2X times Y. And that's kind of an improper function right now because the only input it accepts is X, but the function depends on two other things. It depends on X and Y. So we need to take the perimeter function, solve for Y, and then plug that in. So 200 minus 4X would be 3Y. So Y would be 200 minus 4X divided by 3. Okay. So I'm going to make an area formula using that new information. So 2X times 200 minus 4X over 3. Okay. So that's looking a little complicated. So I'm going to run through now and answer the different parts of it. So the function here, this is part A. Part B is asking me to put this in a calculator, check out the table, and see if we can come up with a maximum area that we can enclose. So, also the dimensions that will produce that. So let me put it, I've got it in the calculator, I already put in Y equals, I just put it in just like I found it just now. Didn't really combine anything, I just typed it just like it was. So I'm going to graph, but I'm not going to see a whole lot right now. You probably won't have this line here unless you have it in color, and I've already graphed Y equals 0 for something else. But you probably won't see much of anything. You may see a little blip right there. Again, if you don't have the color version, you probably just barely see anything at all. So I want to do the table though. That's what this is really about. So I'm going to do second graphs, bring up the table. And this is my dimension X for the length of the fence, and this is my area. So I'm going to scroll down through the list and see if I can figure out the biggest area possible. And this is not terribly efficient on a calculator, unfortunately, but I know about where I'm supposed to end up, so I'm going to get close to it and I'm going to slow down. Now, if we're looking at the areas going by, they keep on getting bigger slightly. Pretty soon they ought to slow down. There we go. Looks like it peaked out right there. The area is getting smaller past that point. Okay? So think of it like a real narrow little fenced-in area. That'd be kind of inefficient. But the wider you got it, the more area you would enclose to a point until it got really wide and then it got kind of skinny this way. And then again, it's impractical. So that's what's going on. It looks like 25 is the best thing I should pick for X. That's going to give me the most area possible. So at 25 for X, you get about 1,667 feet of square feet of area. All right. Now, the book's asking us to do it a few different ways. So there's the calculator way, or the table at least. Next, it asks you to use the calculator still, find the maximum with a graph. So table is good first because now I know a pretty good idea of how to make my window. It looks like 25 is going to be in the middle, and probably want to go up at least to 1,700 to include that maximum there. So I'm going to go to window. For X minimum, I'm just going to leave it because you can have a little bit of cushion. That's not a bad thing. 25 is where I'm expecting the middle, so I'm going to say 60 just to, twice that's 25, or 50, sorry. Twice 25 is 50. That should be where it comes back down the other way. But I'm going to give it a little bit of cushion that way too. All right, Y minimum, and a little bit of cushion, just leave it -10. I'm going to put 1,700 because that's above the maximum of the parabola. And now we should get a pretty good graph. Encases it pretty well. Yeah, there we go. So I want to verify that that point's 25 and 1666.7. So I'll do second trace and maximum because I want to find the maximum of that graph. And we'll just go slightly left of the top of the hill, hit enter. Go slightly right of the top of the hill and hit enter. And then finally hit enter one more time for good measure. And it's sometimes the calculator rounds a little bit. It's using what's called Newton's method from calculus. You'll learn about that next year. So it's an approximation, but it's basically 25. And it looks like we're getting the same thing for our area for Y. So that's a good sign. It's matching up. Now finally is the hard part. They want us to do this by hand. On a quiz, I'm not going to give you something probably this crazy with all these fractions. This one's not as bad as it seems once you factor, but I might expect you to find something like this by hand. Just be ready for that. But I'll make sure that the numbers don't get too crazy and fractions don't get too bad. So let's see if we can work this out. I'm going to distribute some things out. Hopefully it doesn't get too messy looking and hard to follow. But I want the x's, x squared out front. So 2x times -4 thirds x would be -8 thirds x squared. And then this would be 200 over 3, so plus 400 thirds x. All right, it looks a lot worse than it is. When I first looked at this problem and thought about doing it by hand, I kind of cringed myself. But we always take out the first thing that's with x squared. And I'm going to go ahead and again say y equals, because I don't want to deal with all those letters to write. So -8 thirds comes out, leaves me with x squared. Now this really isn't too bad. 8 times 50 is 400. So to get the signs right, it does need to be negative. Negative, negative, make a positive. And that's really it right there. It's x squared minus 50x. 50 times 8 is 400. It's over 3, so there you go. Now I do want to get ready to complete the square. So if I take half of 50 and I square it, I'm going to get half of 50 is 25. I square it, I get 625. All right, I'm going to cheat here a little bit, because I've got to do 625 times 8 thirds and add to the other side. So 625 times 8 divided by 3, that is 5. You know what, let's go with the decimal version since we've already found it. It's at -1666.7. So we're almost done now. By the way, I'll give you a 4-function calculator at least to do stuff like that. So wrapping it up, -8 thirds out front, x minus half of that, so 25 squared. This is going to get added back to the other side. So again, it's looking like it's going to match up this way as well. 25 would be the x value at the vertex, and that number would be the area for the maximum area you could enclose.